Welcome to the lecture series on object oriented analysis and design. We have been looking at a very stiff challenge in the entire computing software development, which is called verification and validation. It is 60 plus years old now, and we are still trying to arrive at working solutions. Ideally, we should have a formalism which is as good as a strong, rigorous mathematical method. We are still not there at that stage, but then we are not happy with the way we can write the requirements in a verbose manner. Lot of English, lot of natural language, 800 pages, 1000 pages. We are not likely to do that also, because we do not have the domain expertise to make it a cogent set of documents. So, in some sense we have struggled with the way in which we should represent the requirements, and by far, thanks to the object oriented analysis paradigm, the notion of model driven development, model based development, these things have become quite popular. Once you have the model done, checked like this, hopefully anything that is true to this model is also verified and validated. I had a brush with one exercise which I did. Alice in the Wonderland was a movie that was more a silent movie. There were no dialogues, hardly one or two dialogues, very old movie script. It was a simple test idea, black and white, not many dialogues. It was a very good, very well picturized, very imaginatively done. Even though it is black and white, it was very attractive to look at. So, can we do it colored? Sort of, instead of putting more dialogues on dubbing, can we get the coloring across the black and white movie? Well, how long will it take? What do we do with that? It is a nice challenging problem to talk. I had good experts, people who have been well versed in the media. It was a challenging problem. So, it is a black and white version. How do we color it? So, there are so many things, it is very difficult. My colleagues are also very quick in spotting many such ideas, saying that if the rabbit is green, looking at green here, the next frame it should still be looking at green, it cannot be a totally different color, the consistency. So many things, we have a nice way of talking about it in engineering schools using engineering parlance. So, how does it translate? What is the way in which I can check whether in every frame the colors of the characters and so on and so forth are happening in a very consistent manner? Is the model well formed? Are the parts of the model consistent? It is impractical to show that this is what we have done. You please verify frame by frame, whatever doubt you have, you tick. If it is working in a consistent manner, then you accept. It is a very mundane way of telling the same thing. It is not simply possible to do that. So, we said we will have a model based development, one of the very early exercises that I have been involved. It is of course with the people who are in the different domain, the people who are doing multimedia. That time it was called, it stabilized as multimedia. They were not calling it films, but multimedia based, multimedia exercise. And when we were doing it, it was a very good idea. We can pick out the model, make the model separately and get it tested. So, it tells that in a notation which we have used for the model, it tells that predictability is there. If I am seeing a blue here, after 7 minutes, where is the blue dominant? After 7 minutes of the film run, not a big movie, it was not at all a big movie, hardly around 20 plus minutes, but the history of that clipping, or that's a full animation, full film, it is a film, it tells that they have taken a lot of time, spent a lot of energy in doing that. So, what it is necessary is to do that model consistency checking, which is very central for formalism, which is very central for verification and validation. What if questions are there, state exploration, these are all the ways in which you can push the model, tweak with the model, make the model do some more ruggedness testing for you. Is the model well formed or consistent is what we have been talking about. So, how many consistency checks? Plenty. What is the best help? UML. If it is cast in UML, do whatever we want, use case diagrams are there, class diagrams are there, sequence diagrams are there, state chart diagrams are there. At each point, at each diagram, you can build those consistency checking. Anyhow, you are doing this, we do not have to spend more time on writing up the requirements, we are all doing the diagrams. At every diagram, please ask these questions. There is a nice game which we used to play called 20 questions. You may not know what is happening, but it is very likely that within an upper limit of 20 questions you will know. If you cannot know after 20 questions, you will not know. That is how it is. This is a thumb rule, it is a theory, it is a game which is called 20 questions. So, simply by cross checking, we can have at every diagram, you can build what are called cross checks. There will be a consistency checking. Between use case diagram and sequence diagram, is it reflected correctly? Well, it says if you can do that consistency checking, there is nothing like it. How? By simply asking the questions, the correct questions at each diagram. So, basic cross checks are there, consistency checking the sequence diagrams. In each class, in the class diagram, there are class, can each message be sent? Is there an association? It is not a single set of questions for all diagrams. Every combination of those 9 diagrams results in different questions. Ideally, we should do the cross checking within that diagram like this. Within that diagram, so many questions can be asked. For any 2 given diagram combinations, we will have a way of cross checking with different questions, sequence diagrams, class diagrams, state chart diagrams. Now, the rational rows tool is very nice. It talks about one diagram, you simply press shift plus another function key, it will change to the another diagram, you will automatically know whether the changing is correct or not. You do not have to ask these questions. Rational rows was doing that. So, the way in which all these 9 diagrams are created and the interrelationships explode is a skill in itself. A way in which that engineering model engineering happens, it is called model engineering. Model engineering happens, lot of things happened, plenty of terminology came, model based, model driven development. So, there were wonderful establishments that kept on telling that this is the best outside of what I described. Simply to relate to what we are doing in the multimedia context, some of the best organizations said that it is the way in which we should develop. Lot of time and money was consumed by the models. All businesses are like that. Once they try, twice they try, 1 year they try, second year they try, third year what will they do? It is simply impractical for them to race against their own business instinct of losing everything. Does each transition have a trigger event? The way in which we are talking about is, it is in theory possible to construct a set of questions for each pair of diagrams which we choose to cross check, but then in practice whatever the tool permits, that comes automatically on the screens. So, when you convert the sequence diagram using a set of keystrokes or mouse clicks into another diagram, that conversion process will tell how much of consistency they are having. It becomes very clear how they are related to each other. How many pairs are possible, what pairs do, it depends on the application. If I want to check the class diagram and state chart diagram, I will do that. So, without dwelling on that further, this was a very nice theoretical plus a desired way of approaching V and V, whatever we have described, whatever has been described until now. However, we started looking at the harder engineering disciplines and borrowing this idea of prototyping. It became very lean. We were not able to scale the V and V in this method. Also, a prototype is usually built to be destroyed. We waxed eloquent on horizontal prototyping, that is 10% of too many features. Vertical prototyping, only 3% of the features will be developed fully. Which is better? Rapid prototyping. We talked about rapid application development also, because if you can develop some functionality, you can do rapid application development. The processes and all got into what was called at that time extreme programming, and then gradually it is now agile. A software prototype is a partial implementation constructed primarily to enable customers, users or developers to learn more about problem or its solution. It is something like very quick fix method. This is how it is going to be there. Is it fine with you? It is not fully built, neither it is telling anything about the completed exercise, but then you get an idea, you get a feel, you get a quick feel for that. The usability engineering started talking about all these things, very quick way of talking. There are so many methods, usability methods, of which prototyping is one. We have concluded with reasonable degree of assurance that some minimal idea about what we are actually attempting to do may happen, but beyond that the prototyping idea did not fly. It is a good idea, but in other harder engineering disciplines, yes, it tells. So, we can show, let us say we are building a car, we can show a prototype, it gives them a better feel for what we are trying to do. A small miniature model of a car, it is there, they get a feel for what we are talking about much better. So, that is how prototyping is a process of building a working model of a system. We are far from working model, but then we tell that this is what we can make work very quickly for you to understand what we are trying to do. Approaches for prototyping, presentation prototypes, we talked about paper prototypes, we talked about simple toy models, exploratory prototypes. We can allow some kind of an interactivity pattern, breadboards. Breadboard remained a very great idea borrowed from the electronics world. The early electronic circuits were all done on the breadboards. It is nice to do on the breadboard and then go ahead and tell that this is how it works, hopefully it works. Evolutionary, well, right now it is like that. As we progress, as I know more about what we want to do, I will build further. Operational prototype, the idea is good, nothing wrong with the idea. How far it is effective in the project or the product that you are associated with, that is your concern. Your goal is this, you think if you follow this process you will attain the goal, that is up to you. These are all ideas which are there, nothing wrong with any idea per se. How effective and efficient will this idea be in the work that you are doing, you are the best judge for that. For that we need a domain expertise in the field of software development. We need people who can look at it. There are off the shelf ideas, you can purchase a few things, off the shelf life cycle models, off the shelf process models, some of them are free. If you look at it, the object oriented methods which we were discussing were all like that, they were methods. Some of them were commercial, most of them were free. See how UML happened in this way. Year 2000 we said this is what is unified modeling language. Throwaway prototyping, most of the times they are like that. Plan to throw one away, you will anyway do that. Frederick Brooks was very nice in telling that. Prototypes are not meant to carry forward. After some purpose is served, we would like to throw it away. It is not useful for discard everything about the prototype, because the remaining 10% may change everything. Our requirements are too volatile. So, we preferred evolutionary prototyping, but then that got quickly replaced by rapid application development, because if you spend more time on evolving a prototype, you can rather convert it into a RAD, how much ever lean it is, how much ever extreme an idea, how much ever agile it is an idea, you will do something which is actually what you are aiming at, rather than realizing at a later stage after 3-4 rounds of evolution also you will throw away the prototype, because it is not going to take further. So, they are all quick and dirty ideas, throwaway prototyping, evolutionary prototyping, requirements are not frozen. Therefore, at some point you will have to throw it away until we adopted what is called rapid application development, RAD models, which were into the agile world. We also talk about all of them now. Tracing, forward traceability, trace requirements from stakeholders to requirements. We also need a reverse traceability, backward traceability. Trace requirements from requirement specification to the stakeholder. We were not able to do it very early because people find it very difficult. Once you talk about a behavior, it is something which they are not seeing on the floor. In an imaginary space, the piece of software that is going to come after some time, after spending so much money, is likely to behave like this. Whereas, as I mentioned earlier, the business translates everything to operations first. operations will come later. This is a way in which we imagine the behavior. So, early days of doing a backward traceability was very difficult. You have to go all the way until the stakeholders get related to what is called an operational level, because that is how they talk. This is a business idea, the development cycle is straight. The idea is good, tomorrow we will start rolling out. They talk about the rollout plan immediately, which is more operational. It is a rollout plan that is necessary. Lot of things have been spoken of, but in practice we have been very thankful to all those 50 to 60 years for telling that this is a stable base. You are not likely to lose much. At the end of the day, you may tell that we are in a lower rung of success rate, but we are not likely to lose much. The system shall accept requirement data, the reverse traceability, independent V&V. Independent V&V fulfills the need for an independent technical opinion. How do I do V&V without knowing all these things? That is what we have been talking about, a third party. A third party quality assurance is stable, but V&V is very rudimentary as of now. A third party V&V, because nobody has the time and the capability to go into so much of internals, and we are not expressing it in such a formal method, but that is a goal. Like we did, there will be a third party quality assurance, we will also want a third party V&V sometime. It is happening, it is not that it is not there, but then the way in which it is happening is not what we planned. Even a preliminary third party V&V is likely to cost 5% to 15% of development cost, that is huge. Most of the projects are 300% cost overrun, 200% time overrun, then this is becoming prohibitively expensive. Even to get 1% of process time for process improvement is becoming difficult. It is now an archaic word, process improvement, but it is necessary to understand why it is there. Three types of independence: managerial independence, financial independence, technical independence. We wish that it will happen. Most of the times I have used these references: the Blum Software Engineering, a holistic view, Colfellow Introduction to Software Verification and Validation, Michael Jackson Software Requirements and Specification, Ludwig Consulting Services, it is there on the HTML. They are all referred. Software verification and validation is desirable, but the approach is not so stable towards software verification and validation. We have looked at the pluses of this approach. Very early we are talking about it, and now we have a paradigm, we have a set of tools that make it doable very early. Several of the ideas were appearing practical, several of the ideas were called only theoretical, but still having that theoretical basis was very essential, because we know that at a time when we have improvised our way of thinking, we have that assurance that it is doable, we can do it. Introduction to Software Verification and Validation, Software Engineering Institute, Carnegie Mellon. These are the references that I have used in this presentation, and to avoid too much of typesetting, I have used them as JPEG frames. Going back, what is the crux of this? It is not this much of detailing, we will somehow have to end up with what we began with, that is what is called an inquiry cycle. It should have a way of looking at an inquiry cycle. Initially it should be based on observations, is still the dominant opinion. A lot of people have been working, whoever have been qualified to observe and make notes for further development, they are the people who will be involved. The prior knowledge is just happening. We need to come up with some way of capturing the prior knowledge. Otherwise, each time we tell that no something is wrong, we will start with a fresh slate. It was much better earlier on when we were in the project mode of operation, we were telling that version 2 will work. This is only version 0, version 1, even then you can still wait, we can still improve. We built fantastic source code control systems, we built a very good piece of software for version control. Even today you can see that, you can see the various versions, how many edits that you have done, what are the earlier edits, what is the way it is going on. Version control on documentation is of primary importance. There are so many online collaborating tools which capture the version control. Even if you make one correction, it will be there. The edit history, it is called technically, is there. Whatever you do, it is traceable. It is just there. We can go back and find. Today, memory is not the concern. That is one thing which we have become independent of. There is no more a serious challenge. We somehow believe that it is there. Anything that you do can be documented. We do not have to clean it up. More importantly, the information security people keep on telling that do not clean it up. It should be there. Investment on memory may appear to be a bit stretching now, but then it pays rich dividends when you end up with some serious horror, and whatever is there as the fault tree is very much on your disk, not elsewhere. So, we kept on investing on memory, we kept on storing all that. What can't the current theory explain is the question. Look for anomalies. What is it that we are doing? Carrying out the experiments, manipulate the variables. This inquiry cycle is essential if only we can make it happen in a manner where it can reflect this primary exercise. We have done a great job. Refresher, V and V criteria, there will be an application domain, there will be a machine domain. The application domain looks like the domain properties essential for carrying forward into the machine domain, nothing more than that. We are very clear minded that this much can be machinizable within the cost, within the time, within the expertise, within the requirement, within the need, whatever you tell, this much is essential to move from application domain to machine domain. So, it is not the domain with its full expertise, but it is a domain that satisfies the need for that application. So, whether we are talking about knowledge or not is secondary, but domain is essential to understand. Till today, we have that same concern that half knowledge is dangerous. This is more dangerous because it is only 1% knowledge. For doing this, you only need this. I is only like this, and we can live with that model of that I forever. Our requirements going into machine domain, computers, programs, domain properties, things in the application domain that are true. Usually, that is what we mean is a domain. Domain knowledge should translate into facts and truths about that domain. Requirements, things in the application domain that we wish to be made true. The application domain should also reflect the same trueness everywhere. Specification, a description of the behaviors. So, what is it that we want? At the earliest, we want this criteria to be satisfied and this criteria to be satisfied. If we can do these four, 2 verification criteria, 2 validation criteria, at every point in time when we are cross checking, there is nothing like it. We have done a very good progress in the direction of verification and validation, which is a challenge over the last 6 decades. Next, we look at how to catch it in an abstract form. A step towards formalism will be like this: an individual requirement R, an individual domain property D, an individual specification S, when it translates into the field of verification and validation, should appear like this. We can come up with another notation. Notations, in notational semantics, we are well versed. We can always come up with a range of notations, we can come up with many things, but then all that should be amenable for what is called a formal method, a model. A model need not be what is called, sometimes we talk about it, a satellite model. It is there. It is a model of a satellite, it can be there. It need not be so tangible, and it is not giving too much detail. We talk about models which are abstract. Every mathematical exercise is a model. Pythagoras modeled an amphitheater. What Pythagoras was talking about was a model of an amphitheater. He did not use that term in that many terms. Mathematicians perhaps never wanted it to be called anything else, because Pythagoreanism was a cult. It was almost magic that he solved the problem. and it happens till today. So, what we really want to understand is the fact that if at all we arrive at a model, then things are amenable for formal methods. Until then, the same tooling, the goal is software inspection, most of the times we do management reviews, then move very quickly to walkthroughs, from there the inspections, the review of software requirement specifications. In essence, what we have done is the fact that the verification and validation is not on UML. Using UML, we want to do something, and we want a notion of verification and validation pertinent to the field of software development. A paradigm object oriented analysis has been very helpful, and we also know that there are plenty of non UML models which come into the exercise. Eventually, all this exercise of defining a goal model, a fault tree, an entity relationship, a mode class, table, whatever it is, will have to be cast in UML, and once it is cast in the UML, we have this objective coming in place. The overall objective of V&V approaches is to ensure that the project is free from failures and meets its user expectations. It remains a challenge. Right through this presentation, there have been some very good references. The Call 88 is a very good book from the very good report written by the Software Engineering Institute, Carnegie Mellon, and it talks about the introduction to software verification and validation. There are so many related topics. The goal of inspection is still elusive. What we are doing most of the times are called code walkthroughs. We are not able to do that in a very well justified manner also, because it is exceedingly difficult to read the code written by somebody else. Even today we keep saying, if you have to change the code by more than 5% what somebody else has written, better throw away the entire code and start from the scratch. That is how we tell. We keep talking about the same methodology. It is hazardous to presume that the other fellow has also seen the functionality exactly in the same manner, written exactly in the same manner as you would express. It is very difficult. So, what we did therefore is a very simple point, that code walkthroughs are good, but then if it is an automatic code generated developed code, it may be amenable for many people reading it similarly. Otherwise, it is very hazardous. We do not write the same ways of the logic. If it is an automatic code generation, if the code has been generated by machining, probably all of us would read the similar way. The code walkthrough happens, then the argument comes, why do I need a code walkthrough if it is automatically generated? It is as good or as bad as a generator. I would rather qualify the generator. I will tell that it is good within these parameters, and I go ahead, take it for granted that the code has been generated. The ideas are there, they are very powerful ideas. We talk about the way in which we need to bring these good thoughts which have been challenging us, intellectually stimulating, and in the process we have come up with a clear method by which a focus on verification and validation very early will give forward traceability, and it will also give backward traceability, which was proving to be difficult in our traditional method. From the business, it should sit pretty on the operations and the operational excellence. That is what they call business translating into action. Now, what are we doing? Business to requirements to development, and then tie up with operations. So, the backward traceability happens very late. So, what we have achieved may not be what we aimed at as verification and validation in the field of software, but we have made provisions where beyond a particular point all these ideas will automatically become doable. We get better tools, we get better people, we will get better modeling ideas, we do better as we progress. So, thank you. We will meet in the next lecture.